Good morning, everybody, and welcome to the before last lecture of their course. It finished, and then everything reaches its end. Today we start speaking about traditional construction, and I chose the West, mostly Europe. On Friday we will spend a bit more time, well, just a short time in Asia, Korea. I'm not a specialist on traditional Asian or Korean architecture, but well, I will share what I find interesting. In the cover, you have an interesting building. This is a replica of a Parthenon, right? Parthenon. This is a Scotland National Monument, which was inspired in the Parthenon, right? So you might have studied already that Parthenon was built actually after the Persian Wars with Greece, right? So Pericles hired the Phidias, and they rebuilt the Acropolis. And Scotland was after Napoleon, right? After Napoleonic works. So why I say it? Because it is interesting that Scottish people were inspired in something that happened like roughly 2200 years earlier, right? With a very similar position, similar historical situation. Well, like a small country, you can say Scotland is a small part of Britain, right? Fighting against a huge Napoleonic Empire. And they decided to make the monument. Actually, Scottish, this is 1826, I think. It is unfinished. And interesting, it remains unfinished. But it is interesting to say how traditional construction and very old construction inspired pre-modern. 1826 is already quite a modern period, right? And they were very good at knowing not only the design and the very precise design of bricks, but also the methods of construction. Also, as you see, they were able to build less than 10% of the building. So they call also the national disgrace or the national shame. Well, interesting, I think, starts that tells that idea of the immortality of architecture as opposed to today's vision of architecture as a commodity. And I thought it was a good cover for the lecture. Very short comments on quiz 6, which was the last one. Just tell that we had 52 attendance, actually was one of the ones having most absences. The average was maybe among best in recent tests and exams. This close to 80%. And we had like near 20 students. That's like nearly 1/3 of the class, right? In the A level. So that was very good sign. But still less than usual, but still a remarkable amount of students. So it's 1/6 of the class having difficulties. So those who have difficulties, please make a small effort. There's still 1 week for the exam, and complete your assignments and be careful with attendance so that arriving late and not catching the final test is like a lost points. As I commented, the most failed question was about the construction manager, which was an easy question, right? But one thing which is unique of the manager among all other agents is that the responsibility is not his own, right? And most of less than half the class had it right, yes. Quite remarkable amount of the class said that it's accountable for the construction quality. But the quality of the construction, the first responsible is the builder, right? And then the second will be the architect, if he has the supervision, right? And very, very far away is the manager. because officially it's kind of advisor. Again, I tell you, it depends very much on the laws of each country, and that may be different, right? But this is one of the interesting things, right? And of course, it's not the architect, not the builder, but the owner who hires it. Okay, so let's go into the traditional construction. And the question is, well, now that we started with Scotland, this is the National Museum of Edinburgh, Scotland. Beautiful interior spaces and quite interesting exhibitions if you go there. So we refer to traditional construction about the techniques which have been inherited through centuries, right? There's kind of popular or historical techniques which are based on trial and error. This is like generations, improving materials, techniques, and so until we have an established way of doing. We can call also the techniques previous to the modern concrete and steel, mostly. You can add glass, right? But glass appeared a bit earlier. So I put that into brackets. But both terms are different, right? But they are used with those two meanings. And finally, it refers also to the buildings, not to the technique, to the typologies, right? It's with the traditional materials, traditional techniques, but refers to the buildings, not to the technique itself. So it's important to distinguish that. We will go a little bit into three of them. But the important thing is, why should we devote some of our time to study traditional construction, right? We are contemporary, we are in the 21st century, and we are excited about new technologies and new ways of construction. So why that interest in traditional construction? So first, of course, we need to preserve old buildings. There's a huge heritage. In the photo, it is a preservation work of Song Kyung Kwan, right? Kwan, the Myeongdang, I'm not sure about the spelling, Myeongdang, the old academy. This is a building originally built in the 14th century, right, at the late 14th century. It's one of the monuments, still is minor, but sorry, to keep that heritage, and could be any monument, you need to be very familiar with those techniques so you will not spoil the building. And that's a very important part of the traditional construction techniques, right? And Korean traditional architecture has a difficulty there, but we will speak about that next day. Then we have to extend and renew old buildings. This is the famous Yeteburi City Hall, renewal by Asplund. This is an architect which comes sometimes. This is the original building, which actually is a building which underwent many extensions and many renovations. And this extension by Asplund. And well, that building was controversial. Now we consider it as a model, an example of building extensions and renovations. But Asplund used new techniques. It is steel and concrete building, but he was very much aware of the materials, the composition, and he did many interesting compositional tricks to have this extension working well, right? Interesting building, you may study it because in terms of design, especially interior spaces are great. So second point, and this is very important because since the 70s or 80s in Europe, and probably nowadays in Korea, there is more and more awareness of the need to really keep this kind of heritage of construction. This is part of our collective memories, part of the culture, and buildings are good as they are used, as they are alive, right? And this is one way of keeping those things alive, so we know, we can read the history of a community through the buildings. And interestingly is the possibility to use those technologies in a new creative way. This was very celebrated a few years ago. It is a kind of a construction with bamboo and mud in a rural area, right? So it is using traditional materials, but in an innovative way, but still a way in which the locals can still use it and build. We already commented, for example, about the use of lumped earth in modern architecture, and there's so many things which we are recovering as we know that we cannot keep overusing concrete and steel everywhere, right? And because there is a limitation, there is a huge ecological impact, and we need to build with some other alternatives. So this is 3 important points. But there's one more. This is Andong Hahoe Maul, right? The famous folk village, which I visited probably almost 30 years ago, over 30 years ago, and many times afterwards recently. And now it became a kind of theme park. Well, this is the entrance museum and information center, right? The typical, which is using Hanok traditional style. It's kind of mixture because there is not traditional museums in traditional Korean architecture that I know. So it's kind of mixture of palace, Hanok. I don't know, think, but well, there's an effort. I would question the use of a glass at the entrance, but that's something that comes with refinement of those bridge typologies. But I was surprised that this building, which obviously was done with a lot of effort, a lot of research on traditional construction and with good builders, was so careless as to have this kind of continuation, right? I don't understand this trend to have a nice front and totally rubbish back at the end. And you can have, actually it would be exciting to have a old and new, right? As a kind of a tension, contrast, as Asplund did, but it's a small disaster. So if you know traditional, not just the construction, but the architecture itself, you can avoid those things, right? So as a summary, we need to preserve the heritage, and that's an important thing. To keep this heritage, often we have to renew, to build extensions, and then we have to be very, very well informed of those techniques. And we can still revive all techniques which can be still used. So, and you go, well, which are the traditional archetypes? Actually, through the lectures, we commented already about the history of the use of the materials and basic techniques. So we have a lot of background already. And this is a repetition, right? We have 2 basic archetypes. This was actually, this is Frampton site in Semper. Remember that we had like 2 important architects in Europe who tried to unify historical heritage with a modern technology and more rational and more scientific construction. Semper in Germany, or Deutschland, right? And Viollet-le-Duc in France, right? They worked almost in parallel, and they had very different lines of work. But look at 2 of the big names, which are like the basis of the change from traditional to modern architecture and construction. And we had the earthwork and roof work, the massive solid construction and the light assembly construction. So let's go to the Western European construction. And mostly what we have is earthwork. It's not exclusively, we have both in Asia, but it's mainly earthwork. And you will see those massive buildings, which this is a cathedral, probably Ronda in Spain. And well, the interior is like carved in stone, right? That's a massive work. Whereas, you know, the difference with the Eastern, especially Korean, is mainly roof work. So there is a massive roof, this is true, but the assembly, the lightness is important part of the character. And then we go to the typologies, right? We will go through the techniques. We cannot go one by one. This is why we have the whole course and we went through them. Here we unify a little bit, but let's go into the typology. That's part of the construction which refers to the buildings, not to the construction. And we usually study the monumental, right? The monumental, which is the largest scale, the palaces, the religious funerary buildings, and often the military buildings also, right? And then we have the more domestic, which can be mostly houses, schools, academias, and sometimes universities and so on, right? So let's now deep into the core of this small lecture, which is the Western tradition. In the photo, you have Avila in Spain, right? This is one of the oldest and most well-preserved Roman walls. Right? That city, this is about 100 kilometers north of Madrid. It's quite a cold city. It is 1,000 meters in height, but it is built over the Roman trace. So it's quite interesting thing. And you can see from the photo, this mainly stone. This is why it remains and could remain after so many wars. I think probably Spain is one of the few countries who had as many wars as Korea had till the 20th century, right? If we end the second part of the 20th century and 21st, other countries are winning us, but that's human nature. So how do we get our knowledge about construction? And of course, the remaining buildings are a very important source of information. Even the oldest, the Roman, Greek, as we saw, the Parthenon, even though it was destroyed in the 1600s by, actually, the Italian bombarding the Turkish. So you have to thank Venetian guys to have a Parthenon destroyed. But there's a lot of remainings, and that allowed to reconstruct and to analyze and to study how things were done in terms of construction and in terms of design. And that massive construction helped a lot to have these things remaining. This is the Caracalla terms, right? This is Paulus Bath, right? Terms, I don't know about the spelling, in Rome. So during the Renaissance, and probably before that, after the fall of the Western Roman Empire, all marbles were taken to make churches, and the building was not longer used, so it ruined and so on. But we have enough remainings, right? Enough data to study. And it was the Renaissance, the moment, it was like over 100 years, over 1,000 years after the fall of the empire, which the passion to study those remainings started to be basic. We have, as we said, inherited technologies, and that is extremely important. Many technologies still are in use, and it will help us understanding and making. In the photo you have, this is like what we call the Catalan vault. Actually, we call it because they still do it nowadays. It is used all Southern Europe and North Africa still. This is done less and less, but it's just thin bricks, right? Light brick with gypsum mortar. Remember that gypsum mortar, we said it hardens almost instantly. So this allows people to make those vaults on the fly without the need of a support. And this is what makes this quite interesting. And you need a very small arch raise to have a lot of strength. So it has been used for ceilings, for stairs, for any kinds of constructions. And you only need a string to make sure you have the arc perfectly done. You don't need any form. You need to be really well trained. because it is hard. Gypsum mortar dries very fast, so you cannot correct your mistakes. And curiously, in my school in Madrid, School of Architecture, which is a huge school, right? One of the laboratories is about those techniques, and there is always waiting list of young students to learn to put their hands in this kind of constructions. And I say this, but you know, we have carpentry workshops and studies in Korea. So difficult to work the refined techniques of carpentry to make a proper hanok, right? You have also the paintings, the colors, which it's very hard to match. And actually, one of the complaints of the renovations is the fake colors we see in monuments and so on. But let's continue here. But probably the one of the most important bits is the written treatise. And treatise, or the books, which started with Vitruvius. We were very lucky to get all Vitruvius collection. This is more than 2,000 years old. We were unlucky to have just the text, not the illustrations. So architects had to imagine all those images, but that set kind of a model to which subsequent architects, and that happens since the late Gothic, right? We have like a Gothic treatise of construction from France. This kind of a model, right, inspires the creation of endless books, right, since the 14th, 13th century up to today. So we have a lot of documentations, and they always wrote about technology, design, aesthetics, right? And that tradition continues. And I think we're lucky to have this. So we have like three sources of inspiration, right? Of course, the monuments, still there's plenty of things to do, and we have many techniques like the 3D scanner, right? The cloud point scanning. This is a technique that many universities are using to document monuments. It can be very precise. It is very cumbersome in terms of calculations. So I was trying to have that added to our digital study on advanced digital studio for graduate school, but it is hard to find people expert and to have all the materials. But I think it's an interesting part to study the existing. The techniques, technologies, you have to find the people who still can do it, right? And the treatise will be the core of what we'll speak today. We'll refer mostly to the books, okay? I stress things which are important because for the final attendance test, those who are still awake, it's not easy to find questions. And well, we may ask some of those things we are insisting through the lecture today. So we will concentrate on the books, okay? Also, all three ways are interesting, and I think they complement each other. The oldest we have is the Vitruvius 10 books, 1st century. The most influential probably ever in history is Palladius, which is almost 1,600 years, 1,500 years later. And to reach that point, right, between traditional and modern, I chose one beautiful book of Viollet-le-Duc, Comment on construit une maison in French, or it was translated in English like a history of a house, right? Written in 1873, which takes us just to from the very beginning to just the borderline between traditional and modern. Remember that Violet was the other name together with Semper, which created this new concept of this new way of looking at traditional architecture. I will not insist much on Vitruvius. We already commented during the lecture, so you can go back if you are interested. It is very easy to find online translations in English. Of course, this is one of the oldest Spanish translation of the French translation. Perrault is one of the French academic classical architects. And probably you may find Korean, right? You may find also printed versions everywhere. So things I will comment from here is Reimer Witt spoke of the origin of materials, and it was scientific. that the discussion of materials, already we saw that except for steel and glass and plastics, everything else was already known, including concrete, also it was an old concrete. And one of the materials which are more interesting now as a kind of possibility for the future is timber. So it's not bad idea to know how people use timber at that time. I will not into this. This is just curiosities. Of course, those illustrations are imaginations from Renaissance and later architects based on the texts. Interesting thing is the bricks, right? So bricks are sized, we said, but you can handle with the hand. And obviously Romans had the slaves, so they could handle like a really heavy, larger bricks, right? Nowadays, we just found out that smaller bricks, and this the Roman bricks a bit larger than the standard brick, are quite versatile, and we don't need to make such huge, massive walls, right? The types of walls, so the bonds we commented in the masonry was something which happened always. The concrete fabrics or the stone outside with the bricks inside, right, to save money or to save material. The Greek way to have the best stone on the exterior and much more normal stones, lesser quality, to just to complete the thickness of the wall, you know, for structural, mostly stability, right? Because usually compressive strength is never going to the limit, but the stability for the bolts is important. Or the Roman way to pour concrete, and this is already maintained almost to the present, right? Let's go to Palladio, which is more interesting. And Palladio, curiously, he writes books and he addresses also technical terms. See how architecture, right, traditionally was about design, construction, and even smallly, but planning, right? But even military and infrastructure. So the architecture was about everything. Of course, the science included aesthetics, right? So there was not this idea we have now to just isolate only one part, because it's very hard. And even though we may specialize in one part of it, we have to be aware of everything else. So what we do is really feasible and makes sense. And it was so natural and so out of the question throughout history, right? But whatever, Palladio just takes the descriptions of Vitruvius, but he adds the illustrations from his analysis of real Roman remains. So he's able to speak about the different kinds of walls, right? The brick wall inside field, this is something which is antecedent of our construction. I went too fast. This is a kind of a wall which is still used, right? And you will see very often having the bricks to solve difficult points and to have some kind of ties in between, and the rest with a much more kind of very rough concrete, let's say, to have just the mass and the volume you need. Only with the stone, you will see this also quite often in all constructions. And then, okay, more kind of brick style, just pure stone. Of course, the concrete wall, which is the cementicus, right? This is taken from Latin, which is like a really modern concrete antecedent, right? It is not reinforced, but it is cast in concrete. The Greek style, again, you see, this is those kind of reinforcement ties. Now we use steel clips or something a bit lighter, and so on. That's regarding the construction of walls. In his Steelbook 1, he speaks about wall construction, and vaults are important. Once you have the walls, you have to make the vaults. That's true. But he mostly goes to the geometry on how to make them. And that makes sense. He doesn't give dimensions, but for the ruins, you have an idea of the proportion, right? The stability, which is about 1/8. So height and the thickness, right, will be like a 1 to 8. This is like a very typical. Also, if you have heavy bolts, you will need to have a balance with counter bolts and transversal walls to support those elements, right? So the moment you have a bolt, just a small arc is extremely strong. You will have to deal only with the vertical and the horizontal strengths there. But the buildings that Palladio proposed were quite simple, and the explanation of the balance is quite intuitive. This is a detail of another detail. See again what we see. This is explaining volts, but this is mostly design. Let me go back. Design section, right? He does not explain what happens inside because he explained before. What explains more the space, right? So you don't need to fill the section with the instructions with details. You can do a very large scale. Here, what is important is to see how this construction creates a given kind of a space. Curiously, in the section, you have the shades to show the space, but in the plan, you have a hatch for the walls. That provides a good background to draw the ceiling plan, which he commented. Modern construction, we very seldom make ceiling plans, but this is one thing we do, for example, always in interior, right? You make flooring plans and then ceiling plans, which can be together or just separated as it happens in this case. Let's continue. And well, door and windows. And again, Palladio doesn't give the carpentry details, but speaks of the proportions, which are necessary to have not only pleasant proportion, but to be integrated in the mechanics of the walls, right? Not to make them very weak. And then chimneys were important. It was the heating, right? So buildings need a chimney. And most interesting is the stair design. I will stress stair because Korea has had already with Ondol a very sophisticated way of heating, much more than the open chimney. Doors and windows, again, the Korean carpentry is much in advantage, but the stair, traditionally Korea, right, has no much stair tradition. Korean hanok are traditionally one floor. Palaces have a small in-between mezzanines, but it's mostly one floor kind of service space. You'll have stairs in military construction and the pagod and so on, but it's not really the important stair to move easily and as part of the composition. And that makes, curiously, even today, right, Korean stairs are a little bit weak in all orders, in terms of construction, design, everything. Almost every stair in our campus, for example, they try to be monumental, but they are not well constructed. The only good stair we had was the engineering building 2. It had a beautiful stair, very well built and very well designed from all orders, but it was demolished, right? To have our lovely parking there. So let me, well, then roof design is also important, but less important. So this is one example taken from Palladio, and see how fantastic this stair is. And this is not just a practical, but it's also something to enjoy going up, right? Enjoy going up and down is kind of a probably what inspired Le Corbusier to speak of the architectural promenade, to walk through the building and see how they are very shallow. This could be 25 degrees. Comfortable stair is 30 degrees, right? So if you have to plan stairs without much, without wanting to put much effort, you put 30 degrees and you will know that will fit. The usual stair, which is about 18.5 by 27 centimeters, probably about 35, 34 degrees, right? It's again most steep. You should use to have a comfortable pace. But this is that slow slope stairs are really pleasant to go up, and they look beautiful. They are monumental, and they create a very relaxed impression. And see how always you have to see the stairs plan and section together. So you see how things fit perfectly with all the steps just the same, right? And the structure, which will hold the steps. So you will have always one wall in between, right? So that monumental stair will have plenty of space and openings, nice experience, but it will be also very easy to build. So this practicality and this design, 50-50 there. This is a larger view. Again, this is a design section to show an example of how beautiful can be one stair, right? So it doesn't show what happens inside, there's somewhere else. Also, Palladio shows the structure of the roof, because probably this is open to the view, or because he thought it is not a solid part as it is the stone. So the basic assembly of timber is shown there. I show this much in detail. We don't need to draw like people did in the Renaissance, of course, but those drawings are very expressive. They are very technical, but they give you a very good idea of the space. We can use our render programs. It's not easy to work in the render sections, but knowing this, we can just tweak and use them to have a beautiful section with shades, with much control, and knowing the effect it will have in terms of giving you the information of the depth, right, of the effect of the building and the atmosphere inside, and even the construction inside, which you can see you have even the brick detail put there. So we will comment more on stairs later, because again, I think stairs are important and Viololithic is a bit more technical. But let's go on. Roofs, Palladio did not work hard in explaining the thing, but everything we see is quite straightforward. Actually, it could be similar to the Korean truss for the roofs, right? It's kind of, probably you may have an intermediate element and probably a column in between, but this kind of typologies in between what we see here in Hanok and what we have in here. Sometimes the load-bearing walls are enough just to support the rafters. Right. Here the section would be around this line, probably. So you have interesting courtyard covered by 4 beams crossed in center without columns. Then a smaller opening to the other side with the vaults, which again need those kind of transversal walls just to have a little bit support for that horizontal load. So much for Palladio. I stress Palladio to have a link between Vitruvius and the modernity. Most interesting is a Viollet-le-Duc, right? 19th century guy, quite a scary face, extremely hardworking, well-organized, and very brilliant mind. He left us a lot of studies from the study of the buildings. So he went into the first way of knowledge we commended. There is such a huge heritage of Middle Ages and Gothic buildings in France that he had material for a lifetime, and he did very well, right? And differently than, well, Palladio was studying Vitruvius and the ruins, so it's kind of balanced. Viollet-le-Duc tried to understand everything from the existing buildings, and he gave us a fantastic set of restoration works. So Notre Dame, for example, was the church was just burnt in Paris a few years ago, and now it's hard to rebuild. He did one of the first restorations, right? Carcassonne is one of the walled city, and so many others. But he left also a huge set of books, right, documenting all the techniques which inspired him new technologies. Surely you studied, or you will study him in history of architecture. So he tried to use cast iron, which was the steel, based on the ideas he got from the Gothic, but not just imitating the shapes. Also, I think he didn't have the opportunity to build and test it, right? But this is interesting because this is the link, right? Between traditional and modern. And see how interesting is that the traditional is inspiring the modern. So knowing the principles and the techniques allows for finding new techniques with new materials based on those principles. And I think that the interesting point. And we could have ended the lecture with only this comment, right? This is the real attitude of an architect who is really interested on the new thing, innovating, if you want to say, and knowing the tradition. So we have this kind of continuity, but without having just kind of archaeological imitation of the past. Just some examples. He has an encyclopedia of architecture, beautifully illustrated, quite expensive now, but still you might find copies, but you can find most of his books open because they are public domain, right? The scans you find in the internet are different quality, but the documentation is amazingly precise and neat. This is one of the castles. There's another example, just the construction of the frames. And look how in a construction drawing, he takes care of the aerial perspective, right? Aerial, probably, or aerial perspective, right? And the atmosphere. So as you go farther and taller, things get a bit more diffused. There's something that is very hard to make in Revit, right? But interesting how precise and how meticulous was the reproduction of those wooden techniques. And he himself would analyze and would criticize what was performing well here and what were the problems, so he could improve those techniques when he was making the restorations. Another beautiful section of the Louvre, the Old Palace in Paris. See again the interest of the design section. You have to know the construction, so you know the perfect thickness of the walls and the vault. But at this point, the drawing does not show what happens inside. That will happen in another set of drawings that he has. So it is helpful for us as a way of documentation, as a way of graphics, and also as an example of precision. It is amazing that those guys were able to make those drawings with just pencil, paper, and just a measuring tape, nothing else. And their own knowledge of geometry, of course, and their good drafting skills. With an army of assistants. But again, I think we can do this. Of course, we can work by hand, and it's quite rewarding. But we can use our computer tools to have graphics which at least are as precise and as informative and as beautiful as those. Remember that the drawing is kind of a anticipation of the reality, or in this case, for existing buildings, kind of a getting as close to reality as possible, so you can have as much as possible the feeling of the building, not the abstraction of the geometry of the lines. So we will concentrate on one book. It was very difficult to choose because contrary to Vitruvius or Palladio, Viollet-le-Duc bibliography is enormous, but there's a tiny, small book about how to make a house, or history of a house. 1873 publication. It was translated into English the year after, so you can find also the English translation. Actually, there is an open format, a better scan than this, which is this from the original edition, but I didn't have time to change the illustrations. Again, this is interesting because this is how the history of house, so the construction from the planning to the ending of the house, with traditional techniques of something which was a modern design in 1873, but this is what we say the techniques of before the Industrial Revolution, or before, not the Industrial Revolution, before the steel and concrete construction, right? Masonry, timber, metal flashing, slate roofs, and so on. So this will help us rounding the whole set of materials and techniques from the basement to the roof, from the foundation to the roof, and also review a little bit all those techniques we saw through the lectures. So it's kind of interesting review. Let's go into it. So to explain the story, there was a rural family in France, and they had the old castle. This is the old-fashioned and not very modern and not very healthy building. So they make a new plan of a modern house, right? Modern. But you can see interesting things like integrating the landscape. So having an idea how you approach the building, probably with a horse carts and so on, but you have plenty of space. The orientation, I think it's not here. Yes, here. So let me go back. So almost all the house is southeast, which is one of the most optimum orientations for living quarters, right? So you have the dining room, the meeting, or the living room with an open window to the garden, as to the garden, main meeting room, and so on, and then working rooms and guests rooms for working, for meeting on the north side, and working quarters. This is like a courtyard with servants' quarters on the northeast, right? So you have some morning sunshine, but they are kind of cool. They have the animals there and so on. And there is a linkage, right, between servants and the house, which is the kitchen, which sits in between. It's quite rational. And they have more floors, but I show the top. So the rooms are huge. You see the size of the bed within the room. And the bathrooms are huge also, but almost all rooms going to the southeast side, right? And the northern part used mainly for just, again, family rooms, meeting spaces, stairs, and so on. So quite modern in some instance. And we see already how we can use many of the orientations with different uses. This is some of the things we commented before, and you see it very consequently done. Roof design, the book just tells you some principles of construction design, then it goes into the construction of the house. But see the geometry, right? So this is the slopes. We have the dormant windows, and always a small space for the water to be able to be evacuated. When we have a small difference, that means that one roof is a bit more steep than the other, right? So if this is even more steeper, it will become much more like this, right? And the difficulty of having roofs collashing together. So this is probably a small slope to have the water running to the side, and this other. So there will be a line here on this side to collect water from one side and from the other, and to be taken to this point. So you see the interest of solving different difficult points that we commented in the lectures. We have another difficult point here, 3 slopes, and then a running point there. And some people coming to class now. So see this point here, which demonstrates to you the effort to make a nice sloped roof, but you have always difficult points to solve by creating new slopes, right? Instead of creating very deep points, which will just accumulate water. So you have 2 points to consider there. You can review your knowledge of geometry here. This is what we saw on Friday, so I don't need to insist. You know already, you can go to the lecture. And this is another image telling you about the foundation. If you have the hill with the strong layer, you cannot do this, right? Because that will make the house just to rotate. As it happened more often than you think. Yeah, there's a famous case of a modern building in Korea. You have 2 apartments, 2 small mansion buildings, in which one is totally slanted, right? And we have some cities. You can look, this is interesting, Santos in Brazil. It's a huge city in the beach, and all towers are very tall. They are all slanted, and all the owners are thinking when this will collapse or not, right? This is quite unique city. And this is not this case, the case of having tall towers in a very soft layer without having enough stability. Well, there are many famous cases, but this is so much common sense, and this appears in the first few pages of a book for a general public. Whenever you build whatever, you need your geological study. For a skyscraper or just a 1-family house, this is very cheap. Whatever the cost is much cheaper than the cost of the building moving down. I cannot understand why so many Korean developers still want to save money on a proper, because they're very very bad ones, a proper geological study, and the proper also measurement of the plots. So you can start with the precise dimensions. Otherwise, what's the meaning of making dimensions in millimeters of the wire? Okay, nice drawing, an interesting point you want to know. The basement excavation, I don't need to explain because you know already what this excavation means, why the walls are much later, and see how the foundations are always a little bit given margin, because we have the weight of the element, right? So we want to have this axis with some diffusion area, so the tension will be a bit more shared and centered, so the pressure to the ground will be mostly uniform. You will have problems of imbalance, right? So important thing there, and the space you need just to complete the work on both sides, right? In this case, a bit tight, but nowadays we are more concerned with safety, so we open a bit more to have a bit more space. But the way of building that time was a bit more different. So they didn't make this kind of waterproofing inside and so on. The construction of walls, this is the detail what we missed in Palladio, but really Palladio buildings were built in the same way. See the thickness of the walls, this may be 80 to 90 centimeters. See the dimensions taken in meters, right? The 19th century was the triumph of the metrical system, right? Of which France, Napoleon were the leaders of that, I think, right? It was kind of making everything rational and so on after French Revolution. And just kind of expression, Viollet-le-Duc was French, and he was using the metrical system very much with rigor. Now we would use centimeters mostly, it says 50, 80, 90 centimeters and so on, right? 60, 50 centimeters. And you see those dimensions, of course, you need a thicker wall for the vault, right? But usually the ground will help with the pressure on that side. But you have usually that kind of 1:8 proportion on the load-bearing walls, which is a proportion which is not bad to have in mind. This proportion, just by coincidence, but there must be something about the mathematics, is also like in towers, right? But we consider like the limit of sleepiness of a tower to be stable, right? You see often 1/8, 1/10, 1/7. Yeah, there are opinions, there's small range, but this is interesting proportion that you will see in the construction. Of course, to have a floor with a heavy vault and very strong vault, you can just fill with sand or light volcanic stone or ashes, so you have a flat ground there. This is another of the illustrations which is important, like the section perspective. We just see the full assembly to show how you can make a basement window and the tricks to reinforce those openings to keep this vault always supported. This is a little bit more complex, and you need really to have a very good knowledge of geometry. Actually, it's cylindrical geometry. You don't work with much sophisticated forms, but still you have to work in 3 dimensions. See the thickness in retention walls, and this is a retention wall. Also, it has the weight of the upper floors. You will see often the proportion being 1:2 or 1:3, right? So to have a proper support of all the pressure of the ground, you need to be really making a thick element. 1:2, 1:3 maximum, and then you have to check it works. Again, the stairs, we can say again, stairs, right? One of the elements which really any European and American handbook will spend full chapters or even full books on stairs. Is something that in Korea are done very casually and very poorly. But well, this is an interesting example, and I think here like Viollet has been creative. Instead of making a vault with a cylinder, it's a bit complicated to make all the steps. It's like making individual arcs in top of each of the steps, right? So it's quite an interesting solution. And again, this is showing the construction. The perspective section is very useful. And here you see this both construction and design. So you're showing the assembly, but also the resulting space. And for that, you need to be a large scale. This could be originally a 1:20 or 1:10 scale, more or less, right? So you have enough detail to show whatever we're explaining there. Some of the problems he saw in old buildings with long spans, so they will affect the very slim bearing walls. So Ledig proposed to have a strong stone element in which you will have the floor, but you will have a larger weight on one side. So both together may compensate to have a much more centered load. So the unbalance will not happen as it happens in those elements. We have a big moment acting over a weak element. Interesting thing. You might find, you might Google it, but Gaudi vaults, you have a lot of this kind of physical study of loads, right? Graphic, and he used to get the building permissions because nobody would believe the buildings could stand, but obviously they stand till today. Well, interesting thing, which is telling about making beautiful building, but also making it stable and working. Assemblies of timber. This is again one. See again the way of explaining things. You have a main elevation, right, and then the detail, of which you can just relate perfectly. There's not this kind of a sudden detail from a very abstract drawing. This is what we call the sequence of scales, right? Sequence scales. And all those guys from the classical and academia are really good. By the way, Viollet-le-Duc was against Beaux-Arts. He created his own school of architecture, which still exists in Paris. Just to go against academia and to do something more modern in that time. And well, we're speaking of the detail of the assemblies. In this case, you use the 3 dimensions to show the assembly just by adjustment of the pieces together, right? The problems of the cutting and the parts of the wood, this is something familiar. And the roof framing, again, we have the perspective section, which shows very well the strong element of the masonry of the building, and then the frame, which is designed in a way that lets maximum of a space to stay in the house. See the slates, it is familiar, right? Even if I don't tell you anything, you will understand perfectly every single detail here. And you see that today is not much changed from before. This is in large part, see how the full structure is kind of floating. Floating is too much to say. So you have ventilation over 2 dormants or dormers. You know, this is elements which are not structural because the structure is in the bottom, but it helps to unify the load. It might have some asphalt in between to avoid the humidity, but allows the structure to have a perfect setting to avoid strong punctual concentrated loads in the fabric. And this also allows to have a longitudinal tie to the whole masonry. So masonry, the AA is not solid, it's made of stones, right? So they are separated. And those dormants will also tie all those elements against horizontal movements. They will give this kind of a perimetral belt to have a better stability in the whole roof. This is interesting construction, interesting point that when you use timber with fabric or concrete, you may consider, because this detail is still we use with variations, but the principle is the same of what we do today. Tricks to deal with the sort of the timber, and again more details of assembly. I just bring them because once you have the big drawing, you can start explaining all the details. And then we start with the construction and see the importance of those structural plans. This is the basement, thick walls. This is just against the terrain, and you have what are the axes. This is B, A, B, but we now put names, right? Structural axes with their dimensions, which will help us draw the building in the space. So knowing the structure is essential. We have to start from there. And this is what we did in the alternative assignments. We know the structure, then everything is easier. See here the drainage space we commented before in this section. And then what we do on site, this is extremely important because we do the same today. We put on those axes again, so this would be probably A, B, C, right? The measurement tape, just stretching string, we have perfect line. Then to have the right angles, we can use the two diagonals to check the distance, or the famous, which was it, 3, 4, 5 triangle, which you know it's perfect angle, right? And then when you have those strings, people just draw the plan. They say draw the plan on the sand. And we'll see a close up of that area. But you see, this is, I don't know the English name, but it's kind of small wooden structure in which you will attach those strings and pull them. You're very precise measuring this point. So when you work, you remove the string, but you have the point and you can pull it again. And this is far away from the end of the building, so you will not need to touch this element. So at any point of the construction, until you reach the ground level, you'll be able to check everything is in that point. From this line, it's very easy to take the dimension to find the position of a window or whatever element which is dimensioned on the building. So this remains until the building is already set to the ground level mostly, and then the building itself will be the reference for the upper floors, and you don't need this anymore. This drawing on the floor is essential because for that you have to provide the drawing, right, with the axis and the dimensions very clear, right? And this is what Viollet-le-Duc was showing in that basement plan. Then this is what we built, what we do to build the vaults, and we need always kind of a wooden form to sustain the stone, unless we use those kind of Catalan vault we saw before. You don't need it. The detail, again, see how as we go up, the axes are not always kept. So the facade usually in classical buildings goes a little to the back. So we have always the load as centered as possible in the building. In this case, it goes to a little stereo, but well, it was just to get those difficult details of the basement windows. This is a drawing of how this basement window will have light while this is still in construction. And the way to make this stone to the exterior and interior with a cheaper stone in between to save money. This is what we saw already in Vitruvius and Palladio. There's the modern elevation to the garden with a glass kind of greenhouse and all the big windows. The detail of the corners, remember that we said in curtain walls, but in every building, the corner is important. So you will have more care, not only for aesthetics, but to make sure those tensions in the corner will be very well supported, not with the small elements which may have more tendency to break. Also, the window detail, see again the section and perspective, showing the seal, right? The protection over the window. So this is kind of a extra dripper before the glass. And for instance, in plan, you can see here the window frame supported by or protected by the fabric, with a small shade which can be totally retained in the thickness of the wall with all the dimensions for the construction plan, section, perspective together, very effective drawing. Some details, interesting details to allow for those. This is like the brick walls we saw before, right? With put in diagonal to make it easier. More details, I will not tell. This is interesting, the construction site. And there's two things to remark here. First, they need to have a space for storage and a workshop, right? So many things are prepared on site. You see the masons and the carpenters working there. So it's one thing we always have a difficulty in any construction now, and this is the planning of the site. It's part of the construction manager, actually, management, and then the safety. Safety. the need of people to walk and to decide how people can work during the whole process with safety, so things can be done on site. Here you see already finishing the walls and preparing just the filling on the sides to create the flat floor. Very basic advice on how to cut stone, so you avoid corners because they may spill. The same thing we say as when we have facades, to avoid cutting elements so thin because they will break, or when you have in plan on section some corner, this kind of detail is also very weak because it breaks very easily, right? You will try to use the full element on the border. Of course, if you can, a more solid element is better. This is just a good illustration of a stereotomy. And again, the stairs, right? And see the effort to have a plan and section together so we can relate perfectly, and to have the count of all the steps. So like 30 and 20, 30 somewhat and 20 somewhat to the other floor with the dimensions in meters. So you can have the perfect position of each, and they have to be all equal in height, and then in length. When it is straight, when it is turning, you have the same dimension at the axis. We'll comment that a bit later, but this equal height in the steps is my fight with Korea. Why cannot do it in Korea? We have always different dimensions in the beginning, in the middle, the last, have stairs, and suddenly the last floor is much higher. And this is so dangerous. And it is just planning that the same as we say in plan, in section, you just throw in section in the wall and then you make the stair, and you can be precise. You only have to preview the finishing. Right? The problem with Korea is you may have a ondol and have a much thicker floor in the ending space than in the intermediate, which you have a bit smaller thing. But it's something you calculate ahead, right? So you make the steps all together. I think 90% of 95% of stairs do not accomplish this, and this is my fight. I wish you, when you make stairs, which stairs are an element in which most accidents happen, right? Most accidents happen in domestic houses, in domestic spaces, and one of the most common is people falling down stairs. And having this kind of irregularity is one of the things that makes those accidents more easy to happen. And we have only 5 minutes to finish, so let me go fast. So this is what I said. You are very careful to make sure all steps are the same. Please, when you design, when you build, when you control, make sure there's not error, because people will say yes, 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 and then in the end, oh, how's up so? How's up so? Yeah, it happened to be larger, and we cannot change because already the stair is built. And this kind of prevision. The other thing, I'll go very fast. We have a rotating stairs. This is what we call a compensated or compensate steps, right? Not sure about the English grammar, in which instead of making a radial position of the steps, you just move them a little bit, so you have a minimum distance in between. So anywhere you go through the stair, you don't have too narrow spaces, right? So you just compensate a bit more, and instead of making the perfectly radial thing, which always different, you move a little bit to make sure all the steps will have a reasonable distance there, right? In this case, some people come in to make the final attendance check. In the case of it was also very nice stair. You see this like about probably less than 30 degrees. It was like a 15, I don't remember, but about 30. I don't remember well, right? So it's very, very, very soft, very nice stair to play. Again, details, very ingenious to make the stair. And then always we have to make a facade section. Look the drip with the position of the windows and all the dimensions. Oh, this is addition. Remember, this is the dripper, which happens a bit high, but still is protecting the window behind. Comments on the windows, the moldings. Again, this is not only for having the water out, but have the effect of light and shade. Then the section, this is obviously design section, the framing of the roof frames. Well, this is again nice drawings. You see how we go from the general to the details, and when necessary, when things are very difficult, you make the axonometric, right? So before, again, the assembly, the cutting of the wood is something people did before, and the detail of the windows. Again, see how you have section and elevation together. We see how things are put, right? The position of the window, and always the human scale, which is something important. In this case, we have also the gutter around there. The assembly of the doors. When I graduated, still we were doing, or generation before me were doing the design of the doors and the windows by wood. And this is quite interesting. Also the windows. Interestingly, this is a window which has quite large pieces of glass, right? But see this section, we don't need to explain. So you will understand perfectly, even though it's not the same, those drippers, this chamber here, this channel on the bottom. The window have only one connection point, but you could have even one more extension there to have a better closure. But see how the details we make now are not much different. Some strategies to avoid the air when you open the two windows, right? And the basic dimensions, 4 by 7 centimeters, which is a dimension which we will use even today in Windows, right? The roof, the slate, no comment. This is exactly the same we saw with the, again, the detail of the nails, and then the gutters and the flashings with the seaming on the ridges, right? All familiar. And then the house is finished, and that's it, right? So just with this to finish, I thought I had one more slide, but okay, we are already in the discount time and we need 2 minutes to make the test. So remember that we did all assignments. Still, you have till next week to add the ones which you missed, and please do them, because even though if the grade is not very good, it will be points that add. For the final exam, remember the core will be roof detail and construction management. In general, I don't remember we have many questions about traditional construction, maybe 1 or 2 questions, not very much important, but probably you may remember some of the things we stressed more just in case, so you have those extra points. But most of the part will be roofs and management, right? This is the core of the lectures. And that's it. Well, this is lecture before this is the ended house. This is, of course, not Viollet. This is Lutyens, right? Which is a earlier 20th century already. And this is a small house in Scotland. He had almost no buildings in Scotland, but this is a house which could fit very much the construction system we saw before. And with that, we end today. Please go to Blackboard, reply to the questions. And if you were awake throughout the lecture, I think the questions are not difficult. Let me know. I will be here in the 2 minutes, just in case somebody has difficulties. Okay, I see people sleeping. Please, it's a pity because this last part is more points on the previous part, and I see like 3 or 4 people who are even more are not taking it. We have to finish, so we are on time. Okay, some people finished already. So I think this was enough. Okay, it seems nobody had difficulties, and it should be finished soon. Okay, almost everybody finished. So thank you so much for your attendance. See you Friday on the last lecture of the semester. Take care and good luck with your presentations. See you Friday. Goodbye.